Euclid's Division Lemma. In this module, we will discuss the Euclid's Division Lemma. Let's state Euclid's Division Lemma in the form of a theorem. Given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where 0 is less than equal to r less than b. The word lemma sounds new. Do you know its meaning? A lemma is a proven statement used for proving another statement. Let us understand the Euclid's division lemma with the help of a simple example. Let us take two positive integers, 47 and 7. Let us divide 47 by 7. So 47 is the dividend and 7 is the divisor. On performing the division, we get 6 as the quotient and 5 as the remainder. We have learnt in the previous classes that dividend is equal to divisor into quotient plus remainder. We can check this by putting in the values. 7 into 6 plus 5 is indeed equal to dividend 47. And also, we have learnt that the remainder is always smaller than the divisor and is greater than or equal to 0. This statement is the Euclid's division lemma in simple words, which in the form of the theorem is stated as: given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where 0 is less than equal to r less than b. Where a is the dividend, b is the divisor, q is the quotient and r is the remainder. Important point to remember is, remainder is greater than equal to 0 and always less than the divisor. Euclid's division algorithm is the method to compute the highest common factor, HCF, of two given positive integers and is based on Euclid's division lemma. Do you remember what is HCF? No, never mind, we will tell you. The HCF of two positive integers a and b is the largest positive integer d that divides both a and b. You have come across a new word, algorithm. Do you know its meaning? An algorithm is a series of well-defined steps which give a procedure for solving a problem. Let us see the Euclid's division algorithm through an example for better understanding. Suppose we need to find the HCF of the positive integers 420 and 130. We start with the larger integer, that is 420, as dividend and the smaller integer 130 as the divisor. Then we use Euclid's lemma to get 420 is equal to 130 into 3 plus 30, where 3 is the quotient and 30 is the remainder. See here that 30 is less than the divisor 130. Always remember that we will not stop the algorithm until we get the remainder as 0. As here, the remainder is 30 and definitely it is not equal to 0. Consequently, we move over to the next step. In the next step, always the new dividend is the divisor of the previous step and the new divisor is the remainder of the previous step. Now consider the previous divisor 130 as the dividend and the previous remainder 30 as the divisor and apply the division lemma to get 130 is equal to 30 into 4 plus 10, where 4 is the quotient and 10 is the remainder. See here again that 10 is less than the divisor 30. Here also, the remainder 10 is not equal to 0, so move over to the next step. Now consider the previous divisor 30 as the dividend and the previous remainder 10 as the divisor, and apply the division lemma to get 30 is equal to 10 into 3 plus 0. Notice that the remainder has become 0. As soon as the remainder becomes 0, we will stop algorithm. At this point, we claim our HCF as the current divisor, which is 10. Therefore, the HCF of the integers 420 and 130 is 10. So let's state Euclid's division algorithm clearly. To obtain the HCF of two positive integers, say c and d, with c is greater than d, follow the steps below. Step 1. Apply Euclid's division lemma to c and d. So we find whole numbers q and r such that c is equal to dq plus r, where 0 is less than equal to r is less than d. Step 2. If r is equal to 0, d is the HCF of c and d. If r is not equal to 0, apply the division lemma to d and r. Step 3. Continue the process till the remainder is 0. When the remainder becomes 0, divisor at this stage will be the required HCF.